All right, welcome back. Just let me get this set up and we'll get going. So, for any of you that um, found this on YouTube, this is part three of my building instruction class, which I call Building Instruction for the Fire Officer. Um, Basically follows Frank Brannigan's textbooks on building instruction. Course objective is based on the New Jersey Division of Fire Safety requirements for fire officer certification, and one of those components is a building instruction class. So this course is being given with Google Classroom as a fire academy class, and at the completion of the classroom portion, um, firefighter, fire officer will get a certification for building instruction, which you can then use for his fire officer certification. So that said, let's get into part three of fire building instruction for the fire officer, right? Ordinary construction. I just want to point out that um, taken from Frank Brannigan's building instruction textbooks, more firefighters have been killed in fires in ordinary construction buildings than in any other type. So we're going to discuss ordinary construction type 3 tonight in part 3. Now, I think, at least from my experience, with the exception of wood frame, the majority of fires and buildings that we have in our response areas uh, could be ordinary type 3 construction. So going back to my other part 1 and part 2, I'm keeping the same theme here that we need to look at the bones of the building. Okay, we need to undress the buildings that we're responding to and attempt to get an idea of what kind of construction we're dealing with. And that's important because the it, when you're developing an incident action plan, the fire behavior doesn't change. What changes is in what kind of construction is the fire located in. So a fire in a fire resistant building is going to pose different problems than a fire in a wood frame building. So you need to identify the type of building construction. And my class, I think I'm also coming at it from the perspective of, as a fire officer, it's not just building construction per se, but what can you do based on the building construction, where the fire is located, severity of the fire, and some common practices or best practices for developing some type of incident action planning for fire suppression. So with our type 3 ordinary construction, pretty much definition is a building with some type of wood roof, wood decking. The bearing walls are more than likely made of some masonry material, whether it be block, poured concrete, reinforced concrete, brick, something like that. The roof and the floor joists more than likely are made of some combustible material, more often than not wood. And I put a definition up here from the 2018 International Building Code New Jersey edition, which basically states that type 3 construction is that type of construction in which the exterior walls are of non-combustible material and the interior building elements are of any material permitted by this code. Now you can see it references Formal Interpretation FTO 14, Now, formal interpretation FTO 14 um, that is found in the New Jersey Uniform Construction Code uh, is an attempt to clear up some of the ambiguity with the um, exterior walls are non-combustible. Right? And what they're saying is that the material for exterior walls in type 3 ordinary construction needs to be some type of similar material to concrete or masonry. All right. So that's one of the catches with the building code is that your type 3 ordinary construction is the exterior bearing walls are going to be some type of um, masonry or concrete type material. So here the picture on the left um, could be any downtown area in any older section of the Northeast or other parts of the country. But what we normally think of as ordinary construction, we used to, and we still do, refer to it as Main Street USA. Because many of your older Northeast downtowns were built in this way. The buildings are usually um, narrow at the front and they go deep. So maybe a 30 by 60, 30 by 80, 30 by 100, you know. And it basically uh, was restricted by the size of the lumber that was available during the time. So it was a matter of spanning the distances. So older downtown areas that were ordinary construction were normally um, narrow fronts uh, with long, deep buildings on the lot line. So today's type ordinary 3 construction, newer construction consists of again a mix of wood, masonry, lightweight steel, but more often than not, the buildings are built on slabs, and reason being is more of a issue of economics than anything else. But we look at this shopping center on the bottom, and we see these nice facades. So, what's the reason for the facades? Well, newer construction, this newer ordinary construction, more likely than not has some type of mechanicals on the roof. Again, um, they don't have building, they don't have basements, so there's really no good location to put the HVAC equipment. They don't want to put it on the same floor as the building that takes up too much space because they're already reduced in storage space because there's no basements. So you're going to find heavy mechanicals up on the roofs of these buildings. And as I talked about earlier in the wood frame section, a lot of these buildings are wood truss, okay, um, maybe wood I-beam. So you got substantial weight on the roof. So any significant fire up in that attic space above the drop ceiling that's compromising the structural members, you're looking at a possible collapse because these units up on the roof tend to be very heavy. So as you're walking through or driving through your downtown area, if you have an older downtown area, an older USA, downtown Main Street, keep up to date on renovations in the older downtown businesses. One of the issues with this type of construction and the older construction over the years, they're constantly being renovated, altered. Um, you're going to find um, multiple ceilings, drop ceilings, and above the drop ceilings, you may find another ceiling, and above that ceiling, you may find the original ceiling. Um, so here's just an example. Um, Restaurant converted into a brewery with large vats, right? On the left, the interior stairs, I'll bring my cursor down here. Here's interior stairs coming down from the first floor, all right? To the right, this would be the exterior of this building. So if you look all the way back here where my cursor is, right, this is that back door coming out. So there's a rear access to this building. So you need to get out there, look at your buildings, see what's going on, come up with a plan. Say, all right, if I get a smoke condition or a fire in this basement, am I going to be able to make access from the front door and come down the interior stairs? Um, do I need to get a line to the rear of the building, force the door, get into the rear of the cellar that way? So again, you need to go out and pre-plan a lot of these older buildings. Just have an idea of what's going on. So here's a picture of the this basement, and again, you can see this is an old building, um, full dimension, 2x6, 2x8 floor joists, 16 inches on center, wood girder, right, valley column, and again, this area here, the older style buildings, they had basements. The basements were used for storage. Basements also had HVAC equipment. A lot of the older basements, they may have had a coal fired boiler. They had coal bins in the basements. The newer construction, there are no basements. Everything's up on the roof. And again, they even have limited storage. They're always strapped for storage space um, because they want the retail floor area. So again, looking in this basement over here, electrical panels. Luckily, this is being converted, so we do have fire alarm system in here, and I'll talk about fire alarm system, sprinklers that in a few seconds. Again, get out and inspect. Um, what you see from the street may be totally different than what you see from the rear. So this is looking at the rear of this building, right? Not the building we're just in, but just down the street from it. And again, if you're out on the street, um, you don't know these windows are back here, right? So you may have apartments up here, but now what do you have? You have roof access. You have some type of roof access. You can get to the second floor. So get out there and inspect your buildings. All right, what about this? All right, fire department connection is a sprinkler, first floor only. Well, why is it only the first floor? Um, you need to get out there and ask questions. You know, talk to your fire inspectors, talk to the owners, ask them if you get in and take a look around. But ask questions. Know your response area. All right, so we talked about the older style, older ordinary construction and basements and cellars. Well, um, the older areas of town where you have mercantile businesses that have cellars, there's always a chance for a cellar fire. This is not a cellar fire class. It's not a strategy and tactics class, but I'd like to, put some things out there for the newer fire officers to ponder. And how would you approach this if you were confronted with a cellar fire? So, cellar fires are the most difficult and extreme dangerous undertaking. Older sections of downtown areas, were constructed with cellars and basements, and these buildings were often referred to as taxpayers. And newer strip stores are predominantly built on slabs. So in this case, we have sidewalk cellar access. All right, show a picture of that later. But a lot of these cellar sidewalk accesses, um, they may have a real steep set of stairs going down to get into the basement. Um, I've actually seen some of them where there's a hydraulic or an electric lift, so that delivery person, they stop down on the street out front. The lift comes up. They put the material, the merchandise on the lift, goes down, and it gets stored in the basement. And these stores, again, they're narrow, but they're deep. So this could be 30 feet wide, 80 feet long. So I want to play this tape, this clip here, Chief Jerry Tracy. They're at a taxpayer fire, ordinary construction, and it shows the cellar access. smoke venting from the cellar access. Just one, one tactic, one set of tactics to use for a basement fire. Pretty much a traditional tactic, not the only tactic, not the only way to fight a basement fire. Um, but just you can get the feel for some of the issues going on here, and just with the understanding that this is an old construction. They have the cellar, the floor joists are more than likely a full dimension lumber, 16 inches on center. Unfortunately, there's a lot of storage in here, a lot of issues going on. But this is about a 3-minute video. I think you'll enjoy it. So we'll let Jerry Tracy take over. You can see they have the sidewalk access open, heavy fires venting, protective hand line in place. They got a protective hand line going into the first floor. And the attack is going to be from the rear. There's a rear door that leads down into the basement, so they can give them a better chance of getting at the same level as the fire.
Of a commercial building, 2-story brick, measuring maybe about 20 wide by 60 deep. First floor front had a commercial occupancy. First floor rear, an apartment. Second floor, 2 apartments. 316 attempting to advance onto the fire in the basement was meeting with extreme heat. Again, accumulations of debris found it very difficult to move the line. We had fire extending up the stairs. We positioned a second line inside the doorway above the stairs leading to the basement to protect that area. In the meantime, we then had a third line stretched in the street to act as a rapid intervention line in case any of these firefighters met with difficulty or there was a compromise, collapse, or a mayday. We had an additional line stretched to the rear, and that company then began the advance, the attack from the exposure-free rear down into the basement. Their initial reports were that they were meeting extreme heat as well, but they did make the push, and they went in, and they did knock down the main body of fire. And for right now, like I say, I'm so proud of the firefighters in both Battalion 49, my battalion, Battalion 46, for the professional performance that they give us every day. And this job was certainly one that showed their commitment, their aggressiveness, and it makes us proud.
All right, so here's a old picture that I found that we use when we used to teach cellar fires. One of the traditional methods was hand line on the first floor, protection hand line, a line going into the basement stairs, pushing down to the front, ventilation of the sidewalk entranceway. Firefighters were able to get down and attack the cellar fire at the same level as the fire. There wasn't any fire coming up the stairs, so that was just one method, one tactic. There's other tactics out there. This is just one way that could be used, and I just want to bring out that from Chief McAniff, uh, who wrote the book Strategic Concepts in Firefighting. An experienced chief officer accepts one of his greatest challenges when he encounters heat and smoke belching from the cellar of an unsprinklered, non-fireproof building. So again, cellar fires extremely difficult. Um, other than wood frame, you know, um, residential structures, um, high probability if we have ordinary construction buildings in our towns, we do have a chance of having a cellar fire in one of those buildings. So again, get out there, get into the books, get into the tactics books, see what else is out there, and come up with a couple plans that you may have to put into effect when you're the IC someday. So again, we're not doing cellar fires, but I just want to throw some of the tactics out there, and it has to do with building construction. One of the other issues that, again, in New Jersey, um, the picture to the left, there's a sprinkler system. It says basement sprinklers only. Uh, we look at windowless stories. Right? So a windowless story is defined in the building code. And again, it all depends on access by firefighters versus is there windows that we can get a hose line into the basement from the exterior? Is there a set of exterior stairs that we can descend and launch our attack at the same level as the fire? If not, if it doesn't meet the criteria, if it's a windowless basement, it's going to have to be protected with a fire alarm system, an automatic fire alarm system, smoke detectors that go to a central station, and depending on the square footage, they may also need to include a sprinkler system. So again, when we talk about um, fire department connections, they're supposed to be labeled. If it doesn't, if the sprinkler system doesn't cover the entire building, the FDC needs to have a label on it that tells us what part of the building is covered. So again, here's a perfect example. It tells us there's a basement sprinkler. And again, some of the older downtowns, here's one of the sidewalk accesses. Um, and again, some of the stores, they had electric lifts, hydraulic lifts that would come up. The truck would pull up, put merchandise on, we lower down, and they would store equipment in the basement. Um, just want to bring out the gas meter, right? Um, all these basements, at least in my town here, they switched over from low pressure gas to high pressure, which is um, much safer. But you're still going to find some of the buildings, you're still going to find the gas meters in the basement. So again, you need to go out, take a look around, do drills, do company drills, do in-service drills. Look at your buildings, know your building. All right, as Chief Dunn says, you know, your battle space. You got to know your battle space. All right, so concealed spaces. Again, another big issue with ordinary construction, especially if the buildings have been around for a number of years. Um, there's always different tenants moving in, moving out, different kind of occupancies taking over, a lot of renovation. Again, you know, drop ceiling. I can tell you, in my firehouse there was 3 ceilings, uh, 2 drop ceilings before you get to the second floor deck. So this is just an example here. Ordinary older construction pose serious issues, right? Concealed, hidden spaces created by years of renovation can hide fire. Right, in this case, ductwork from restaurant exhaust hoods running up through multiple floors can spread fire throughout the building. So in the picture to the left was a duct fire that I had as a chief. Right, our firefighters need to get to all floors and be ready to pull ceilings and walls to expose hidden fire. Okay, this was prior to thermal imagers that are a great tool for those fires. So um, prior to thermal imaging cameras, we had used feel, sight, smell, uh, pull ceilings, pull walls. Um, I just read a fire engineering article on fifth alarm fire in Manhattan that started in a restaurant and went up through the ductwork and hidden spaces, and involved 5 floors, up to the roof. So you can have a lot of problems in these type of ordinary constructed buildings. Uh, Cocklofts, right? Fires that begin or extend into the cockloft are probably the major cause of total loss of taxpayer buildings. And that's from John Norman, retired FDNY. So I'm just putting up this scenario that I had a number of years ago when I was district chief at a fire that basically involved a cockloft in an ordinary constructed building. So here's my fire on arrival. All right, 3 stores on the first floor. Um, Ordinary construction. There was a wood frame dwelling that was built over top. So this would be similar to a taxpayer, right? So again, on arrival, fire's going pretty good. Started in the wood frame building, wood frame dwelling on the top. Uh, Ladder company is just arriving. So here's a picture of the next, hours after, once the fire was extinguished. We have the cockloft up here. So the cockloft is basically the space above the ceiling, but below the roof deck. So it's a flat roof. Normally, the term cockloft um, is used when we're talking about buildings with flat roofs. If you have a pitched roof, terminology may be different. Maybe call it an attic space. Again, it's whatever terminology your department uses, that's what it is. What you can see here, fire got up into the cockloft, or actually burned down into the cockloft. Masonry walls, right, pretty much held the fire to this one store. We had some examination holes over here that we cut, see if we had fire spread into the cockloft, but we were fairly successful to limiting the fire to the original wood frame dwelling and the store below. Again, this just happens to be a 3 foot cockloft, just so you get an idea of the size, right? So 3 feet space up there, so a lot of wood, uh, very very difficult to get access to the cockloft. That seems to be a problem. A lot of cockloft fires is access to get the hose streams to get into the fire. Concealed spaces, again, older construction. I used this picture before. Another fire that I had. All right, this was the original fire store. All right, fire started rear of the store, extended up an open chase into the attic space. Now, some may call this a type 3 ordinary construction. Some may call it a wood frame. I don't think you're wrong with either one, but I'm just going to use this as an example for my ordinary construction today, just to show you some issues. So again, the fire was, you know, in the rear of the store. Again, old building, maybe built in the 30s, 20s or 30s. A lot of renovations. Okay, void spaces all over the place. Just a plenty of hidden spaces for the fire to travel through. Again, so it's a good example for a type 3 to illustrate the combustible attic and cocklofts. It's also a good case study for fire extension through combustible void spaces. So the fire started in the rear store, extended up into the cockloft or attic space. Again, there was no draft stopping. I know I haven't gone over draft stopping. You can look up draft stopping in the building code. It's basically just if you have a combustible attic space or you have a combustible cockloft, uh, every 1,000 square feet, there needs to be some type of barrier that they call a draft stopping to try to slow the spread of fire through the cockloft, through the attic space. Um, newer construction, they're using gypsum board to set up to make draft stopping. But in this case, no draft stopping. Again, this was built prior to any codes, and you can see the size of the cockloft or the attic space. Unfortunately, area where the first two ladder struck the waterway on the parapet. All right. Again, be careful. If you have a aerial device that has an exposed waterway, all right, you need to be careful. The chauffeur on the turntable was concentrating on landing the bucket on the roof and missed the distance to the parapet. Um, and this roof was also similar to a bowstring. So what happened was he was looking at the bucket, lost lost sight or lost concentration on where his waterway was on the ladder, and just the way the roof is configured, it was tough to get the bucket into position. Put the ladder down on top of the cornice here, broke the waterway, and it was at about that time we were going to be switching to a exterior attack, and this ladder was then out of service. Had to be removed, had a special call in an additional tower ladder to take its place. Same building. Again, here's the additional tower ladder that was brought in before it got into operation. We do have a stream in operation over here. There will be another stream coming in from this direction. And this fire was all up in this attic space. And again, one of the issues is the roof is still on the building. Um, you're not going to get to the fire because the roof is in the way. The roof is put on the building to shed water. So if it sheds water during rain, it's going to shed our fire streams. And again, there's really no good way to get into the attic, the cockloft space, unless you got up here and started cutting, which would be, in this case, it would be almost a waste of our time to try to get enough access to get hose stream into the cockloft through here. I stated earlier issues with the cockloft fires with access to the seat of the fire. Some tactics that possibly could be used: distributor nozzle, cockloft nozzles, trench cut. Again, trench cut is a specific type of defensive action, and again, it's meant for certain type of buildings. You have to know your buildings. You have to know how to do it. You have to practice it. Um, so, just another technique. Prior to putting any firefighters on the roof, the incident commander needs to identify the roof construction and the fire location. And is the risk to firefighters worth the reward? Again, older construction have dimensional lumber. You may be able to get up on a roof, cut some holes, get a distributor in there, get a cockloft nozzle in there. If you're looking at lightweight construction, you shouldn't even be standing on the roof. So very important that you know your buildings. All right, so here's something we don't see often, but they're known as tiebacks, right? The stars and the diamond shape in these pictures are basically there to keep the brick and the siding from falling off, right? It's attached, the brick is attached to other masonry, but it's weakened. We don't want to have a curtain collapse. So these stars, they're basically, there's bolts and rods go back into the masonry and are just holding the brick veneer onto the building. All right. Okay, let's see. Hotel Vendome, good example of ordinary construction, um, years of renovation, um, issues that um, most likely nobody caught when the renovation was being done, but happened in Boston, 1972. 9 firefighters were killed. And this happened after the fire was extinguished. It happened during overhaul. So real quick, um, we can see here that during renovation, well, before we did renovation, there was a girder, all right, that was carrying this one bearing wall with this column. And this column came down to another bearing wall, which then transferred the load down to the foundation. Doorway down here, so more than likely was adequate. But what had happened was they cut a hole in the wall for a ventilation duct when they installed air conditioning. And that ventilation duct, the hole, was right under the column that was transferring the load down to the wall. So after the fire, we talked about impact loading and live loads, water, firefighters. So at some point, uh, there was a straw that broke the camel's back, and this column punched through this opening where the duct was, and then it just brought the rest of the building down. And 9 Boston firefighters were killed that day. You can see here the one ladder company, one ladder truck is just buried in debris, right where whole section, this whole section of building came down onto the truck, and there were firefighters up doing overhauls at the time. Okay, bowstring truss roofs. Um, not not a lot out there. I guess it all depends on what part of the country you come from. Not It's not something we see a lot of in new construction, but they're out there. Sometimes they're tough to identify. This happens to be the Wallbound supermarket fire. The fire happened in 1978 and killed 6 firefighters. So at the Wallbounds fire, um, bowstring trusses, uh, there was a rain roof, additional roof put on over top of the original roof because of water leaks. So there was a ventilation nightmare. You have large areas of storage space up in here. Um, you could walk into this building. I think the original companies that came into the building almost reported there was nothing, no smoke, maybe a slight haze. So this is a giant heat sink up here. So you get a fire up in here, it could burn a long time before anybody even notices it's up there. Um, Lost one of the trusses. These trusses span um, upwards of, could be 20 feet between trusses, even more. And you lose one truss, you lose, if it was 20 feet between trusses, you lose a 40-foot section of roof right here. It just caves right in. So if you have bowstring trusses in your area, go out and identify them. Um, Let everybody know. Put it on some type of run card, some type of CAD that, hey, there's a truss roof in the building. Um, you need to take that into account. And Hackensack Ford, 1988. 10 years later, 5 firefighters are killed. Uh, Similar type fire. Fire up in the um, bowstring truss void. Firefighters were in the building. Um, they more than likely should not have been in the building. They should have been withdrawn. But that's my opinion. Um, but there was a collapse. There were firefighters trapped, and we lost 5 guys that day. So again, history tends to repeat itself. This is just a picture from the Hackensack Ford fire. Fire burned undetected in a huge truss void for detection. Interior crews may not see any fire or smoke, or may only see a light haze. Right? Any fire seen venting through the roof of a bowstring truss, an evacuation signal should be sounded. All right. Collapsing bowstring trusses can hurl walls and debris a distance more than twice the wall height. That's from John Norman. All right. Exterior insulating foam. You probably see this more often than not, and you don't really realize it. But it could be used on wood frame construction. It could be used on ordinary construction. Um, it's on there to make the building, to give a better appearance to the building. They put the foam on. They could put an outside some type of mastic on. Um, make the building look a lot different than what it actually is. So the exterior foam siding usually covered with a stucco material to look like masonry. Right? If the stucco is breached and the fire gets into the foam, expect rapid extension. Again, this could be a block wall also. Here's the Monte Carlo Hotel in Las Vegas, Nevada. Fire started up on the deck, and all this up here that's burning. That's all the EFIS, or the extruded foam material, that was on fire. Parapet walls. You see an issue here. So this is your town. You're the fire officer. You may drive past this every day. You know, or do you look up there and say, all right, if I get a fire in this building, um, I need to keep my troops out from underneath, because this doesn't look very stable to me. A hose stream striking this could knock it over. Almost looks like a pretty significant windstorm might topple this thing over. But with the parapet wall, ordinary construction, all right. A lot of them are sitting on a steel I-beam lintel, all right, and they're just pretty much, a lot of them are just freestanding. This I-beam heats up from fire exposure. We know when we heat up steel, it's going to expand. This expands. It could parapet, topple this parapet right over. All right. So that's a good example of how a parapet is constructed, especially older style, older buildings. And again, hose stream striking at, heavy snow load, anything. Definitely be thinking uh, some type of collapse issue, collapse hazard, collapse zone. There's our steel, again, our steel I-beam under here. Heats up, it expands. The parapet wall's gonna come down. Just a video of a parapet wall collapse. And again, um, don't know what the conditions were, whether it was windy. Obviously, the building was fairly deteriorated, and gravity is always affecting our buildings. It always wants to cause our buildings to collapse. So gravity is a big issue here. So let me go back to that. Okay, so just think if you're fighting a fire in this building and your guys are standing out on the sidewalk. Um, and again, take a look at it one more time. Um, do you know how unstable this is? Unless you've inspected the building, you wouldn't know. Um, looks like a fairly substantial walls up there. It doesn't even look like a parapet. And it comes crashing down on top of you. So let me go to the next slide. All right, curtain wall collapse. All right, I think we showed this in the wood frame section. Curtain wall, basically just our brick veneer, is attached to the wall with some type of tabs, metal tabs, and over the years you get water behind here. Uh, the metal fasteners rust, they rust away, and all of a sudden you have a collapse. So party walls, again, I'm going back to this same picture that I showed previously, but again, this was 1965, February. This is a party wall right here, all right? This is what pretty much kept the fire from extending to the delta side, to the delta exposure, or the number 4 exposure. Again, fire's up here in the this pool hall. Party wall was in the previous picture. The building to the right is the original fire building. All right, so there's the party wall right here. And this is what the building looked like after the fire. Here's the party wall. Um, there really wasn't much damage on the first floor. All the fire was up here, and this was a pool hall up here. Again, a parapet up here, okay? And, the building sat vacant for a number of years. Well, not a number of years. The building sat vacant for a year after the fire, almost a year, until it was a snowstorm next year, February, and that this whole wall over here, this section wall, collapsed down into the parking lot. Right on it's the Bravo division, the north side. And again, like I said, almost a year later from the snow piled up, and it's collapsed. All right. I did a little digging into the history of this. I did find some articles, newspaper articles. There was innuendo that maybe the building inspector at the time, knew that this building was unsafe, but it was never required to be demolished. So it was demolished after it collapsed. This is what it looks like today. All right, there's the party wall. All right, so again, the party wall is basically a wall that is shared by 2 different buildings. You can see remnants of, more than likely, where there were joists up in here. All right, so firewall, and we have a resistance table for firewalls out of the building code. It's going to give you what the fire resistance rating in hours is for firewalls between buildings. So this would have been a 3-hour wall. So we're talking about ordinary construction. We said that the exterior walls, the bearing walls, have to be made out of masonry, some type of masonry material. The floor and ceilings are usually made out of some type of wood material. So in this case, especially the older type construction, they had what they call fire cuts in the floor joists. And you can see the way the floor joist is notched at an angle. So that way, if the floor collapses, the floor joist collapses this way, the wall remains standing. So you can see this picture here. There's no fire cut in this joist. It's square. So if it's in the wall square, it collapses. It's basically a giant lever which can knock this bearing wall over. So with the fire cut, all right, the way it's set into the wall, it's only resting on the bearing wall here. It comes up at an angle. The floor joist collapses. It falls out. The wall remains standing. So that's called a fire cut. And again, if you have older buildings in your town, get down into the basement. take a look, you may be able to see some of these in some of the older buildings. Here's a picture of a older building, and you can see the way the joists here are cut at an angle, reminiscent of a fire cut. Alright, so I don't know if anyone saw this video. The tiller just happened to be driving down the street, and all of a sudden this building decides to collapse out of nowhere. Again, older buildings. I don't know if it was a vacant. If it was open to the weather, it was all deteriorated, and again, it collapsed. But just a example of you think you have time to get out of the way, you don't. When it comes down, it comes down. You may never even know it. So keep your head on a swivel out there. Again, know your buildings. This is just a good illustration. Now, again, this lift over here, think of it, replace it with your tower ladder. Here's your tower ladder. The guys are working in the bucket doing overhaul after a fire, and it doesn't take much. 1 second the building's standing, and the next second stuff's coming down. Yeah, that's one of your guys. You know the guy that's going to be up there in that bucket, uh, overhauling, pushing, pulling stuff. And again, got to be careful during overhaul. Um, Minimize the risk, especially something like that. Keep your collapse zone intact. Um, expect the unexpected. All right, again, this could be, fire department operating during overhaul. Um, just substitute the guy that's the construction worker with one of your firefighters doing some overhaul. Yeah, there's the guy on your truck company. I'll get it, Chief. Don't worry. If that wasn't bad enough, then the wall comes down on top of it. Wait for it. There she goes. All right, so some key points, some takeaways uh, from this part 3 of our building construction series. Ordinary construction, again, it's often called Main Street USA. It's based on a type of construction that was used in older downtown areas. Ordinary construction is a mix of combustible and non-combustible materials, mainly combustible roof and floor assemblies with masonry bearing walls. Newer type 3 construction could include more steel and load bearing walls. Right? Ordinary construction in older buildings may have numerous concealed spaces, including multiple roofs and even multiple ceilings. And the older Type 3 buildings may also have basements and cellars. And you're not going to know this until you go out there and either you get a report of a fire or you've been proactive and you've been out there doing inspections, taking a look around. So here's my information. Again, you want to check out some other videos that I have. There's my YouTube channel. So I'll be talking to you again in part 4 of our 6-part series for building construction for the fire officer. All right. So see you soon.